Okay, so we've been talking about fractions. We've learned how to add and subtract fractions. We've learned how to multiply fractions. So we're going to get into the slightly more complicated, but not that much more complicated area of dividing with fractions. Some of you already had experience with this. You know there's just an extra step, but we're going to back up a little bit. We're going to get a little bit more in depth into this concept of dividing with fractions. Now, when I say dividing with fractions, that could mean something like this. We're not going to do this problem yet, so just hold off. So if I said 3, the whole number 3 divided by 1/4, or if I said something along the lines of 1/4 divided by 3, we could definitely work both of those out. But when I say dividing with fractions, that means that somewhere in this division problem, a fraction is involved. And we don't need to know how to work with that. But before we figure out the how to do it, what's important? What do we need to figure out first? Before I figure out how to do this, what's important that I figure out first? You need to phone a friend? Who can tell me, before we figure out how to do something, what do we need to figure out first? We went over this with multiplication and adding and subtracting. That's part of how we figure it out. So look at it this way. Look at it this way. Say, Passion. Yeah, that's okay. No, that's that again. We're looking. That's the function of how we actually figure this out. What's important also, and probably before we actually go to the whys and hows of figuring it out, is what are we trying to figure out? What does this mean? Why is this important? So we're trying to figure out what we're trying to figure out and why we're trying to figure it out, and then we work on how we figure it out. And some of you already seen the process of figuring out how we divide with fractions, because you've seen it with multiplication, you've seen it with adding and subtracting. First, let's talk about why we're going to do it. First slide, please. Okay, so when we're talking about fractions, pizza is always a great thing to go to, right? Because pizza, when you think about it, it's meant to be divided, right? Unless you just got a huge appetite and you eat pizza whole, you're going to divide this thing up, especially if you got a family, you got friends over. We're going to cut this up. And everybody wants a fair share, right? Everybody wants an equal share. So when we cut this up into fractions, we're going to cut it up into equal fractions. So this is a square pizza. Was that Little Caesars? Square pizza? I don't remember. One of them has square. The other is it Little Caesars? Okay, yeah. Okay, go ahead and go to the next slide there. Okay, so we're going to cut this up into sections like this. Can you all see the lines? Okay. All right, so who can tell me how many sections this is cut up into?
16.
16 sections, okay? So that means that this guy right here is what fraction of the whole pizza? Who can tell me?
1/16.
It's 1/16. So this one right here equals 1/16 of the whole pizza. If I cut this up into 16ths, as we just found, and then I ate the whole pizza, what fraction of the pizza would I have eaten? 16/16, which is one whole. Thank you. 16/16, which is one whole pizza. Okay, I'm not going to do that. Okay, but we're just dealing with the theory right here. If I fed this to my family and we all ate 16/16 of the pizza, that means we would have eaten the whole pizza. Okay, go ahead and go to the next one, please. Okay, so this square right here, would you agree that this square right here is a fraction of the pizza?
Yes.
It's a fraction, and we've already established what that was. What was it again?
1.
Say it, everybody.
1/16.
1/16. Yeah. So this little guy right here is 1/16 of a pizza. I'm not sure how big this pizza would be in real life, or if that would even be considered a legitimate pizza. Okay. Go ahead and go to the next one. Yeah, 1/16 of a pizza. Okay. So now we know what we're dividing this into. We know what each one of these units is. Okay. So we're talking about units of 1/16 of a pizza, which is 1/16 of a whole pizza. Okay. Go ahead and go to the next slide. Okay, now let's say we made an order, we had dinner, and the next day we're going to reheat the pizza and we're going to go over what's left over. And this is what we had. We did a big order. We got a big family here. So, what value is this right here? 1 whole. What value is this right here? 1 whole? 1 whole. What about this right here? What do y'all think? What do you think?
It's not that.
It's not 1 whole. But what do you think this part here is?
I got it. 4/16.
Not quite.
13.
Almost.
12/16.
12/16, okay? Because if you look, see how, go back one slide. This guy right here, okay, about that big. Go ahead and go forward again. So if you see it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it looks like we have 3 whole pizzas left over, and we've got 12 portions or 12 parts of a whole pizza left over, which means we have, go ahead and go to the next one. Right, so we're trying to figure out what portion of pizza do we have left over that's available to eat. So who can tell me what portion we have among all of this? We already know what this fraction is, we know these are whole, so put together, what do we have?
We have 3, 12, 16.
3,
And 12.
3 and 12 16. Go ahead and go to the next one. Yeah, 3 and 12 16 pizzas left over from what we originally started off with. We don't know what we started off with. What we know is what we're dealing with now. This is what we've got left over after last night's feast. Okay, either we ordered way too much pizza. We probably ordered way too much pizza. This is the case.
Well, they only have 4
Okay.
left.
Well, we have 3 whole pizzas left plus 12 16 of another pizza.
They ate 4.
Well, they ate 4 pieces out of this one. Who knows how many whole pizzas they have left? That's not part of this problem right here, too. But if we were going to say, so if I just gave you a problem and I started off with 3 and 12 16ths, we wouldn't necessarily know what does that 3 and 12 16ths stand for. What does it actually mean? Well, that's where we're going back to what I just said a little while ago. We're talking about what are we trying to figure out, why are we trying to figure it out, and then we get into the how do we figure it out. Okay? So go ahead and go to the next slide here. Okay, if you took 3 and 12 16ths, let me erase this. If you took 3 and 12 16ths and you simplified it, because if you can simplify, you always want to simplify. We have 3, change this out. We have 3 and 12 16ths. The 3 whole right there, that's good, but we can simplify 12 16ths because the number 12 and the number 16 share, oh, that's a lot of hands, share what number, what factor in common? I'm going to go here.
They can go
Be multiplied?
divided
Divided by 2.
4.
Yeah, and they can both be divided by 4, so let's take the bigger number. What's 12 divided by 4?
3.
3. And 16 divided by 4?
4.
So we know that the fraction 12 16ths can be simplified to 3/4. The 3 whole, they just come on over. So we know we have 3 and 3/4 pizza left over. Okay, so now we've got this amount of pizza left over. We know how much we have. We simplified it, and we've taken it to its simplest terms. So now we have to figure out what are we going to do with all this pizza. Can you go forward to the next one, please? Okay, divided by. So there are 2 ways we could look at this. We could say, if we knew how many people we were feeding this to, we could divide 3 and 3/4 by the number of people. Or, let's say, it doesn't matter how many people we have, everybody gets one particular portion of pizza, and that's it. Let's see how many people we can figure out. We can figure this. So let's say if everybody gets 1/4 of a pizza. That's all you get. You don't get any more. So what problem could I write up here in order to figure that out?
3 and 3/4 divided by
3 and 3/4 divided by 1/4, okay? So, let me write this out. 3 and 3/4. And it's important to remember, this is the only time you want to use the word and, is when you're dealing with fractions or decimals. You say your whole number and then the portion that's left over. You don't say, if you were to say 123, you don't say 123, because that's not good math terminology. So 3 and 3/4 divided by 1/4. That means that no matter how many people there are, the most they can get is 1/4 of pizza. So now we get to figure out what. If we know this is how much pizza we have, and this is how much pizza anybody's allowed to get, what do we figure out at the end?
How much is left?
Not how much is left.
how much there was.
No, we already know how much there was. That's right here. Exactly. How many people can we serve? When we get our quotient, which is, what's a quotient again? Let's see someone from the back. There you go. The answer to
The division problem.
the answer to the division problem. When we get our quotient, we will know then, as you said, how many people we can serve based on these rules. The only thing is this. We've got, what do we call this kind of number right here?
No, a mixed
A mixed?
A mixed
Number.
fraction.
Almost, you almost have it.
Mixed number.
A mixed number, okay. It's a mixed number, which is a combination of a whole number plus a fraction together. Make a mixed number. We can certainly do this problem, but what do we need to figure out? What do we need to do first?
We need to do mixed number and
Right, we need to change the mixed number into an improper fraction so then we can actually do the math correctly. See, now we've gotten, I'm gonna review real quick, we've gotten the what we're doing. We're trying to figure out how many people we're trying to feed. And then we got the why we're doing it because we know we have this amount that's going to be divided into chunks of 1/4 of a pizza each. And we'll get our answer. So we know what, we know how, we know what, we know why. Now we're going to go to how. Okay, so we're going to convert this number right here into an improper fraction. Can someone define an improper fraction for me?
It's where the top number is here.
That is true. Can you name those things correctly? The top number and the bottom number?
The numerator.
Okay, and give me the definition again using those words.
It's where the numerator is greater than.
Very good. It's where it's any fraction where the numerator, the number on top, is greater than the denominator, the number on the bottom. So this is really good for Team Omega as well. Who can remember how we do that? What do we do first?
You multiply 3 times 4,
Wait, let's call them by their names. We multiply.
the whole number 3
Mhm.
to the denominator 4.
Okay, so we multiply first. We multiply a whole number by denominator. What do we get?
We have 12.
We get 12, and then
We add it to the numerator.
we add it to the numerator, so we get 15.
And you bring the 4
4 down.
And the denominator does not change. So that means we have this 3 3/4 is 15/4. And if you look at this, we can prove that because how many fourths are in each whole?
4.
There are 4 fourths in each whole. So how many do we have here?
4 fourths.
Plus,
4
and
fourths.
that makes how many?
That's 8.
8 fourths. Plus 4 over here is
12 fourths.
12 fourths. And then we've got 1, 2, and all this together makes a fourth. So 12 plus 3 is
12.
oh, wait a minute.
12 plus 3 is
36.
15. 12 plus 3 is not 36, it's 15, okay? And it shows right there, if we took all these pizzas and we changed them into fourths, we would have 15 fourths. Well, that's pretty simple because we're dividing this by 1/4. So we have 15 fourths divided by 1/4. Now there's a couple of things you can do, there's a couple of steps you can take to simplify this problem, but first I want you to look and see. Let's look at fourths and let's think about, let's call them shoes instead of fourths. We've done this a lot this year, right? So if I had 15 shoes and I'm breaking them into groups of 1 shoe, how many groups would I have?
15.
15, because if you look, and here's the how of it. If you look first off, well, 15 divided by 1, well that's just what? 15. And then 4 divided by 4 is what? 1. Any number divided by itself is 1. So then I end up with 15 over 1, because when I divide 15 fourths by 1/4, I end up with 15 wholes. And how do we write 15 over 1 properly?
Just the whole number.
Just the whole number 15. So if we take this number and we put it back into our original problem, this is how much pizza we started off with. What is this number right here? What does that represent? This right here. What does that represent? How much pizza everybody gets. And we take this number as the answer and put it right there. What does this represent? You said it a second ago. Right, so how many people could I feed if I gave everybody 1/4 of a pizza? You know, 15 people. So using this formula, that's a very good point, very good point. We'll get to that in just a second, but thank you for reminding me. So we know that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and believe it or not, this actually makes 1/4 of a pizza, 15, and everybody gets 1/4, that means 15 people can have 1/4 of a pizza based on this, okay? But what if, I'm going to back up here, and you guys already know the answer because we've already done the problem one way, but let's do it a different way. What if I said, well, we have 3 3/4 pizzas here, and there's 15 people in here. You see where I'm going with this? So what problem could I write to figure out if I have 3 3/4 pizza and there are 15 people I need to feed? What problem could I write to figure out how much everybody gets?
15.
And think carefully. This is what I have, and I have 15 people I need to feed, so I need to do what to this? Divide it by, I need to divide it by 15 because, and remember, everybody gets an equal share, right? Nobody's getting more than anybody else. So if I have 3 3/4 pizza, I need to figure out how to divide it 15 ways. and then I'll get some number, the quotient, which will be the answer to the problem, okay? Once again, I want to review, the what we're doing is we're cutting up pizza. And the why we're doing is because we know we have 15 people we have to divide it equally among, so we need to figure out how much everybody gets. You all recognize this is the same problem, just kind of done in a different way?
Yes.
Y'all see that? Okay, just illustrating the point here too. Well, what did we say, let's go ahead and backtrack. What did we say 3 3/4 would be if we wrote it as an improper fraction? 15/4. We'll use what we had before. So 15/4, that's how much pizza we have. And then we're dividing it by 15. Well, how do we write a whole number as a fraction in order to use it properly here? Back row.
15, what?
How do we say that? How does that look like?
15, slash 1 at the bottom.
All right, we say 15 over 1, exactly. That's how we write the whole number, 15. We write it 15 over 1. Okay, again, there are other tricks that we could do in order to make this easy, but I want you to take a look at this. Can we divide straight across here?
No.
Yes.
Yes.
Divide.
Yes.
Take a look. What is 15 divided by 15?
1.
It is the number 1. And that would be our numerator. What's 4 divided by 1?
4.
Any number divided by itself is just the same number. So look at what we got as an answer.
1/4.
So that means that we have this much pizza and this many people waiting for a piece. What does everybody get? Well, they each get, as we saw before, 1/4 of a slice of pizza. Okay? Now, before we move on to our next activity, as I was so graciously reminded a moment ago, we need to check and make sure that we've done this correctly. So we go back to what? We're working with division, and we go back to what?
Multiplication.
We go back to multiplication. So we ended up with 1/4, and we have, we start off with, what was it, 15 people? We only had 15 people, and each one of them gets 1/4 of a slice, so we're going to use multiplication to figure out, do we get back to here? 3 3/4 slices. Because we did the math, and we probably did it correctly, but we always do what? We always check our work. We always check our work. And because multiplication and division are what to each other?
The opposite.
The opposite. So you can use one to undo the other, and thereby check your work and make sure. So we're going to use multiplication, 1/4 times, and we had 15, which we wrote as 15 over 1, just to make it simple. And like I said, I've explained the what and the what and the why, because the what is, we had 1/4 of a pizza for each person, 15 people. The why is because we're checking our work now. We're just going to make sure we did this correctly. And so, who can tell me how you multiply fractions?
Multiply, simplify.
Multiply, multiply, simplify. This is the how we do it. It's more important that you understand the what and the why, but this is how we do it. You multiply numerator by numerator, denominator by denominator, and whatever you get, you simplify. Okay? That could mean changing, simplifying numerator and denominator, or it could mean just changing it from an improper fraction back to what kind of number? A mixed number, right. So if we multiply 1 by 15, we would get what?
15.
We would get 15, and then 4 times 1, we would get what?
4.
So we have 15/4. We've seen that number before, so we're looking good. But we can't leave it like this because this is an improper fraction. So the way we look at this, what did I say every fraction is? Who remembers? Every fraction is a division problem. So what we're going to do is we're going to say this actually means 15 divided by 4. So essentially, how many groups of 4 can I make out of 15? Let's go with someone who hasn't raised their hand yet. You guys know this. All right, let's go with front row. Okay. How many groups of 4 can I make out of 15?
3.
I can make 3 full groups of 15. Or excuse me, 3 4 groups of 4. Well, how many of these 15 fourths, how many of those fourths would I have needed to have used to make those 3 wholes?
12.
I would have had to use 12 of these 15s, which leaves how many fourths left over? If I had 15 fourths and I used 12 of those fourths, so how many fourths do I have left over? No, I have some left over. No, think about it. If I had 15 fourths, think about it as shoes. If I had 15 shoes and I used 12 shoes, how many shoes do I have left over?
3.
I have 3. So the answer would be 3 and 3/4. And if you guys remember, that goes right back to what we started off with, 3 3/4. Okay? Seem pretty simple?
Yes.
We're going to do one more because I have another method I want to show you guys. Some of you have seen this before. Who can name the method that we use when we have when we have a division with fractions problem? What do we call that? Just the initials. Keep, change, flip, okay? Now, there is an important concept, whether you are working with fractions or you're not working with fractions. You guys do not need to remember this, but this is useful information. This is what we call the multiplicative inverse, or what did you call it? Remember you named it properly a little while ago? The reciprocal, okay? What a reciprocal means is, we take any number, and would you guys agree with me that any whole number is actually still a fraction?
Yes.
Yes.
Okay, so somebody give me a whole number. Somebody who hasn't participated yet. Back row.
3.
3, okay. Keep it simple, okay? So if I were to take the number 3 and write it as a fraction, what would it look like? Try again.
3-1.
3 over 1. So the whole number 3 can be written like this as a fraction. Now, if I were to say, what would be the reciprocal of 1/3? The multiplicative inverse. What does it mean to invert something? You remember? You answered this earlier. What does it mean to invert something? Exactly, very good. To invert something means to just flip it upside down, okay? This now, the multiplicative inverse of 3 over 1, or 3 wholes, is 1/3. Now the reason this is important to know is because when we are working with dividing fractions, if, I'm just going to make up a multiple division problem of fractions. Let's just keep it simple. If I said 1/4 divided by 1/2, okay? Well, we could certainly do this problem if we wanted to, but another way we could look at this is if we have 1/4 divided by 1/2, this would be the same thing if we multiplied it by its reciprocal, by its inverse. So if I took this and rewrote this problem, 1/4, keep the first one. What do we do to the sign?
You change it to a multiplication.
We change it, so keep, change, and then what?
And we flip it.
And then we flip. So keep, change, flip, so 1 over 2 becomes 2 over 1. So what I'm doing now is this is the same problem, except that instead of dividing by this, I'm just multiplying by its reciprocal, which means I'll come to the same answer. And now, because we're doing multiplication, how do we multiply fractions again?
Multiply, multiply, simplify.
Multiply, multiply, simplify. What is 1 times 2?
2.
What is 4 times 1?
4.
Okay, so now we've got 2/4. Can we simplify?
Yes.
Yes.
What do you think, back row?
2. 1/2.
Explain that.
1/2.
Explain that. No, I'm not going to explain that.
We could divide those 2 by 2.
Yes, we can divide both numerator and denominator by 2. So what is 2 divided by 2?
1.
1. And what is 4 divided by 2?
2.
So we see 1/4 divided by 1/2. Well, that equals 1/2. Okay. So essentially, this is how we actually work with dividing with fractions. Okay. So here's what I would like you to do. I would like you now to break up into groups of 3. And here's my expectation. So there's going to be 3 of you in each group, and that makes an even class right here. So there's going to be 3 of you in each group. One of you come up with a fraction. Another one of you come up with a second fraction. The third person divide those 2 fractions. Okay? So go ahead and get into your groups, and let's go ahead and practice.